what evidence would convince you that the Earth is spherical?
Physical measurement of the Earth's surface.
Yep, and we do that daily.
No, you don't, because we've been trying to figure out how to do it for years.
You don't?
Well, tell me about your physical measurement of the Earth's surface. Tell me about it.
You got to understand what he means by physical.
He means tangible. He means tangible. Tangible.
Like, I ask you a question. What evidence do you need? You can't
tangible.
Ask me.
An actual measurement, not optical.
Whoever that is.
Not optical.
Not talk for the other person.
How would you even see the measurement if you're not using optics?
Shut the fuck up, Lael. We've gone over 20 times.
That's dumb shit, Lael. Jesus Christ.
You're not using optics.
Curve, get control of this guy.
Down. So we can't use So when you say we can't use optical, what do you mean we can't use optical?
Long range optics. Obviously, we can use a tape measure and look at it.
What I mean
nothing where refraction can come into play at all, or perspective.
Refraction can come into play between me and the tape measure.
Let's not be jackasses. If we want to be jackasses, I'll bow out. Let's not be jackasses.
Seriously, Dross.
Play even worse.
Dross, I expect more from you, Dross.
Hold on. There's going to be refraction. You're calling somebody a jackass because they're bringing up the point that when you say no refraction, they're telling you, well, bud, in atmosphere, you can't have it.
This is not the first time we've had this conversation, Curve. You know what we're fucking saying. Don't be a pedantic asshole.
If you guys want to do this, fine. No curve.
Okay, hey, that didn't mean take my spot, Lemon. Now, Brandon.
I'm sorry, you've been edged out.
I will mute you if you do that to me again. Okay?
Well, then
I'm not being a dick. I'm just warning you fairly.
Boring.
And I'm not trying to intimidate you with it. Just keep in mind, don't tell me what to do, Brandon. Now, you're being as you're calling him an asshole for bringing up that there's refraction. And what you have not done is define what, in your subjective opinion, acceptable refraction is, the difference between that and then what becomes what you consider unacceptable.
I want to be able to walk up to multiple places with a tape measure, put it up against some kind of deviation from the ground to a known straight surface and measure the deviation with the tape measure. I don't think refraction is going to come into play with something like that.
Serious? But what you've just said, you just debunked yourself.
No.
How do you get the known straight
surface? You just said that you want to get a tape measure and then walk to somewhere that is flat and then walk to another place that is flat.
No, you just butchered it horribly.
Well, that's what flat earthers do every day.
All right, well, explain, Brandon.
Well, you're a flat earther.
You know we don't. Curve, you know we don't know how yet.
Yeah, well, we don't know how. You're trying to figure it out.
You know we can't do. Or not yet.
Well, you can't show us curvature otherwise.
Yeah.
You have no way to do it, so that's what you demand. That's what you're saying.
No way to do it yet.
The question was, what would you accept as evidence of curvature? I answered the question. Now you're unhappy with it.
No, I'm pointing out your answer and what it involves and what it means.
Well, that was my question, refracting lenses, ideally just a laser.
Shut up, Lemon.
Would you agree that we are
spending
a lot of time and effort trying to figure out how to do this, Curve?
So that was my question. What evidence would you need?
Did you see all the lines I had Rumpus draw last night? You know how much effort that took?
So, but what you're going to do, the evidence you need is to go and stand at point A with a measuring tape, and then go and stand at point B with the measuring tape, or somehow have a measuring tape that's, say, even 60 nautical miles long, right? And then measure 1 degree of change.
No. You're
Well,
misunderstanding.
no, hang on. You're talking about measuring tapes. Like you do not have a concept of scale.
I do. Yes, we do. We understand this problem very clearly.
Why does
Let
the
me
measuring
clarify
tape
for you.
come into it? Why does the measuring tape come into it?
We understand the problem very clearly. So just imagine this, because I don't have a diagram I can bring up right now. We make a straight line in space above the surface of the Earth. Straight, not curved, straight.
Yeah,
For
and
say for 6 miles, right?
Horizon, that's fine. Yep.
Sure. 6 miles long, it's a straight line. Now, we measure that against level, meaning the level of water, all along that 6-mile straight line. On around Earth, the middle compared to the ends, there should be significant deviation between the distance between the straight line and the surface of the water level. On a flat Earth, that deviation would be similar for those 3 spots, exactly the same, technically. Understand?
Whether it's a flat Earth experiment, that won't happen.
I'm planning to make this happen, Chris. I'm planning to do this.
Yeah, but they've been planning for 5 years and nothing.
That's fine. That's fine, Chris. I'm not a flat earther, and I haven't been here for 5 years. I know you guys are going on about this test for some reason, but the picture I was showing to you, that I brought you up, Brandon, because I knew you were in here. But I mean, I wanted to give a bit different argument than what was given already. That picture, because I think that's
Kosho,
right there.
Kosho, are you holding the rumpus to the same standards as you are, Brandon? Are you holding rumpus to the same standards?
What standards am I holding Brandon to?
Well, he was supposed to do a test, which he never did. How come I don't hear anything about him?
How come I never have talked to Brandon about a test? Like, what are you talking about, dude?
Rumpus couldn't get
our
the wood
tests
in his
are already
car.
done, dude. Have you forgotten that?
You mean the one that he couldn't get the wood in his car?
The results are published.
He couldn't put the wood in his car?
It's all there already. We're not required to do tests.
Rumpus isn't even in this room. I don't think he's ever been in this room.
They're not required to prove. Jem just said it. They're not required to prove their claim, Essie.
Yeah, Rumpus has been in this room, but that's neither.
We don't need to prove the claim.
You have a baseless assertion on our hands there.
All the tests that we can do, we've already done. We've done them as accurately as they can possibly be done. We've sent a spacecraft into space and scanned the surface of the Earth with a radar. So,
or you got lied to. Well, either one. Possibly, but I don't think that's very likely. There's no evidence that that's occurred. So I'm going to go with what's already out there. There is nothing that I can add to the database that's already out there. So that could be better in any way than the stuff we've already got. It's as good as we can possibly get at the moment.
I'm gonna go with the over 16,000 archaeological sites we found in Mesopotamia and the Levant, thanks to satellite imagery that we did not know about, did not know were there, and have actually started excavating, a proportion of those sites. But all of those sites have now been marked.
The other thing I was going to say,
before we get into Druss's showroom of knowledge, the point is we aren't required to do tests. You guys are.
Yeah.
Required to prove your claim. Yes, we know it's what the fuck is that?
I didn't say we aren't required to prove our claim. That's not what I said. But nobody's required to prove a claim, are they? They're required to present evidence for it. And my point is the evidence for our claim is already there. And we can't add better evidence to it or more extensive evidence to it because it's already very extensive and already very good quality.
And this can't be falsified, right?
Can I ask
Yes, of course it can be falsified.
How would we falsify it?
Well, we would have to demonstrate that it's incorrect in some way. And
how do we do that? totally fail to do that. Well,
how do we do that?
How do we
it
do
would
that?
be very,
That's what...
it's very difficult because it's correct. So I don't know. It's an impossible task.
Can I just ask like a practical question?
Go ahead.
Like I'm not sure who I'm talking to, like Jeremy, someone else. Like, have you guys flown on airplanes lately?
I guess yes.
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 Okay, so have you flown on an airplane out
Probably
of
just make the point, Rich, rather
mountainous-
than do this Socrates thing, because we'll be here all night.
Let's
assume that they
trying to
travelled
be
on an
here all night,
aeroplane,
but-
shall we?
Okay, so the point I'm trying to make, right, is that the majority of airlines will use, like out of mountainous areas or where there's obstacles per se. They'll use the SDS. I can't remember exactly what SDS mission it was. Where they, radar scan the Earth, right?
NASA.
So we use that.
You mean the people we think are lying?
Because it's accurate, right? Down to hundreds of meters. Even now, because things don't, like geology doesn't change that fast, but we still use that and to make departures or landings so you don't hit hills. Now,
We're not contending that your mathematical model doesn't work.
No, this isn't mathematical. This is something that's been measured.
Sure.
And we use it. So we're not using like a mathematical model. It's something that's been measured. So, and we plug that in and we know that we're not going to hit hills if we have an engine failure, for example.
So the ellipsoid reference
So
system that you use isn't a mathematical
flying
model?
on an airplane?
It's a measured model.
Because, hey? How does... Yeah, it is a model and it's predictable, whatever. But what I'm saying is that we mapped it with the space shuttle, which gives us more accurate information so that we can actually take off out of airports. Well, even, Jesus Christ, if I say it like GPS, satellites, we can take off with more weight and follow, what these, what those things were, like those, the radar images were from the 90s, then put an overlay of essentially like GPS to make sure that you can actually follow it correctly. So are you happy with that?
Do you think I'd be here if I was happy with that?
It's still a conspiracy.
I mean, that's the problem, and this is the sad truth that whenever they are encountering an evidence, irrefutable one, they try to butcher it and stab the evidence as it's fake conspiracy theory that even they cannot prove. So yeah, people living in their own la la lands.
Yeah, sorry, we don't trust the government. I apologize for that.
Yeah, no government, no scientists, nobody. We only trust our flippers, our
Like a lot of it,
brethrens.
a lot of the people that do this stuff are private companies, doing the surveying and things. They're
Like,
private
honestly,
companies.
I'm planning.
They've got nothing to do with the government. They're not on the stock market, as a public entity. They're just a private company that surveys terrain, right?
Honestly, I was thinking, like, my first time being here, that in my university, like, I might make up a group for our group project, this annual project, and launch a camera into like stratosphere, like near the vacuum, or like where we can get the curvature, so we can also see the curvature, and we can stick up a camera on there. But even that, I believe, even if I attempted to do this and I succeeded in capturing the shape of the planet, I think I will even be stabbed. Even my evidence will be ridiculed by the flippers. So I don't know, man. It's like useless attempts doesn't really matter anymore to them.
Well, you made the right choice.
I wanted to go back to this picture you said wasn't evidence. Although you did say, well, it was on while you were taping, that it was unexplainable. But your response before was the reason this is happening was because the light doesn't travel forever. But as I stated when I was trying to show Rich, the light is reaching the lens of the camera. So why isn't it reaching the clouds?
Oh yeah, sorry, I totally lost track of that.
No, you're fine. You're fine.
Thanks, Coach, for reeling it back in.
Oh yeah,
because you wouldn't see it if the photons didn't reach the camera or your eyes or anything, right?
Right. So just
and you can only see things because of what it reflects off.
It's taken at twilight. What's your point? We know there's twilight.
Yeah, no, that's not the question. The question is, why is the sunlight able to reach the eyes of the person? Doesn't matter if it's twilight. We know this happens at twilight.
There's still some light. The intensity of the light is not that great. There's still some light, obviously, which is brightest when you look at the sun, but it's twilight.
Yeah, but then why is it not reaching the clouds beneath the plane? It's reaching the plane. It's not reaching the ground beneath the plane.
Where's the denser air? Where's the steeper angle to the sun? Down at the ground, right?
Yeah, not above the clouds though. I mean, if it's reaching the plane's like right above the clouds.
The higher
you go, the clouds are high
enough
to where they're floating in the air. So it's not there's not a big change in density from where the clouds are and the plane is.
The higher you go, the longer you're going to have the sunlight.
They're only on a globe. That doesn't work on a flat plane.
It does work on a flat plane.
That's
how based on the principle.
Well, I already talked about it. Just like
I know,
in
but
the ocean.
it's not a valid claim. It's not a valid refute. I'm showing you that the plane's directly above the clouds, like a small distance above the clouds. The density is not going to be so different from the top of the clouds and where the plane is that the light can't reach the clouds for some reason, but can reach the plane.
It's not. What's the density? How high is that plane?
It's directly above the clouds. I would probably say it's, I don't know, maybe 500 feet above the clouds at the most. Maybe just.
How do you know that from looking at this?
I'm just looking at the picture. Yeah, and also I know that the density at the top of the clouds is not going to be a great difference from where they are.
No, you can't know that just from looking at a picture.
No, just by the fact that they're above the clouds.
Otherwise, I can claim that I can tell just from looking at a picture, and that means I have a video of satellites being chucked into clouds.
Yeah, but we don't need to play that dumb. We have the gradients of like air density and the atmospheric pressure.
That's
at
what I'm
different
saying.
levels.
So how high is the plane?
Yeah, you don't need to play that dumb. It's above the cloud. It doesn't change that a lot.
We know that the clouds for the clouds to be up there, it has to be less dense, and most of the density exists at the bottom layer. Once you get up to where the plane and the clouds are, the density is not changing by much from one place to the next.
That's not true. What's the density at 30,000 feet versus at 3,000 feet?
Well, that's not the difference here, but
well, how do you know? You don't even know how high
because the clouds are at 3,000 feet. We know that the clouds don't climb to 3,000 feet.
If I was to have a guess,
clouds can go up to 60,000 feet. They can go as low as
you can't ask
0.
a guy a question if you don't know the actual answer. But if I was to have a guess, and I just heard 30,000 feet, 40, whatever, I'd probably say 2.7 psi. If I was to have a guess, and I want to make that fucking clear. If I was to have a guess, mid-30s, 40s is around like 2 to 3 psi. So does that satisfy your question?
Talking about the air. He's talking about the density, though.
My point is, there's obviously
he said PSI. He was talking about air pressure. He said, "What's the PSI at 30 whatever thousand feet?"
Yeah, and it's coincide
Brandon,
with
the
the
PSI
density.
doesn't matter if you're worried about the density.
It does. Absolutely, it does.
Well, it matters if you're worried about oxygen getting into your lungs, into your bloodstream.
Right now, we're talking about refraction.
Yeah, right. Well, either way, the question was, what's the PSI at that altitude? I just gave off the cuff, which I think is probably not too far from correct. Well, it's probably terrible, but I don't know. That was the first thing that came to mind. Curved.
If you're up in low pressure, low density air, and you're looking down into thicker and thicker atmosphere, denser, higher pressure, all that below you, and you're seeing the sun below you. Keep that in mind, because that's paramount. You're seeing the sun below you, Brandon. I want you to remember that. Okay, now the sun's near the horizon. You're looking downward. Now let's pretend the sun is somehow down below you. What is the effect of the refraction there as you're seeing it from the lights coming up through the denser air into less and less dense? The light's going to bend towards the denser medium, causing looming, making the sun appear a little higher than it actually is. So if the sun is not just appearing below you, but actually below you, when you're at 30,000 feet, what information might you be able to glean from that, Brandon?
There's so many assumptions packed into what you just said that I don't even want to attempt to unpack it. It's like, go ahead, Curve.
What assumptions did I make, Brandon?
I understand what you're saying, Kurt.
Well,
quit accusing me of
all,
assumptions and tell me what they are.
In that picture, you're assuming that the sun is loomed, right? Based on what you just said.
I'm not talking about
is refracting downwards.
Hey, Brandon, just to be clear, I'm not talking about this picture specifically. I'm talking about when you're at 30,000 feet and the sun is seen down near the horizon, seen below level from your position, below your horizontal. That's what I'm talking about. Now carry on.
Finite vanishing point. We have a finite vanishing point. That's how our vision works optically. Things appear to vanish into the horizon, right? What's the problem?
Well, vanishing point, a drawing technique.
It's not a drawing technique.
In a drawing, everything has the same vanishing point. In reality, if you want to try to apply a vanishing point to anything, the vanishing point for any object is only valid for that object, basically due to its distance and actual size, and when it becomes too small to see. That's a vanishing point for that object. You do not have a still shot in your vision. Your eyes can move around. It can move relative to a vanishing point, like on a picture, and basically rendering this attempt childish and ineffective. Do you have anything else you'd like to try, Brandon?
So you're denying that in reality, we have a vanishing point that we see with our vision. That's what you're denying right now?
What did I just say? Do you listen?
It sounded like you denied it. I'm just trying to clarify.
Well, I deny that you have a vanishing point. Yes, because that's grammatically incorrect.
Okay.
You have virtually infinite vanishing points, unique for each object. How about that?
There are vanishing points, right?
Sometimes,
not like in art class. Not as in art class.
Yes, as in art class. Yeah, that's what they based it on, see?
No, the vanishing point in the art class is not object dependent.
You're talking about John
you
Williams
can draw
Scott.
as many vanishing points as you want. Listen, we're just talking about a theoretical situation where you have parallel lines all going away from you, let's say. Okay, I understand that depending on the direction you look or the direction an object is, it's going to have different vanishing points, right?
What's the definition? What's the definition of parallel lines and the vanishing point? What's the definition?
The definition of parallel lines?
Yep, and vanishing points.
Okay.
They will never meet. Or, to turn it another way around, they will meet at an infinite distance away. All vanishing points are infinitely far away.
That is incorrect.
That is straight out of the reference books on perspective.
Now, if you're invoking the Rayleigh criteria, or if you're invoking John Strutt, which is what I think you are doing, now we're talking about a different thing. We're talking about the resolution of a singular object at range and the distance that we can no longer resolve that against another object next to us.
I want to hear why he disagrees.
Which is a really different thing. But we don't see the sun going to a vanishing point. We don't see the moon going to a vanishing point. They sink below the horizon. There is no vanishing going on because it would reduce equally across the entire body of the object, which it doesn't do.
No, that's true in that sense. Yes. My point was to say that to address the Curve's point about it being below your eye level.
Well, yes. I mean, in reality, it is. In drawing, it's not, because we just tend to use it colloquially. So we draw to the eye level if we're doing a technical drawing. But in reality, when we look at it, as we gain altitude, the horizon drops. Fact.
I know, but in his model that he was implying, which is the establishment model, nothing ever drops below your eye level, right?
No. Curve would absolutely disagree with that. I would disagree with that because that's not what we see in reality.
He said as well.
He said to you earlier that the horizon. He said to you earlier that the horizon was below eye level, and you have to look down to see that in the sun.
On a flat plane, if we were looking straight ahead, would anything above our vision that starts off above our vision and moved away from us move below eye level?
No, because
that's what I have. Contend is inaccurate.
Hal, make him explain. Make him explain, Lyle. Shut up.
Yeah, and my explanation is that in reality, there is a finite vanishing point. And we do see things move below our eye level. That is what we measure things at distance. They do move below our eye level. Now, you'll tell me it's because of curvature.
How wide?
So it defies.
Right?
How can you say measuring at a distance as well? I thought you can't measure.
Guys, let one person ask the question. He's asking a question already, so don't ask 5 questions at the same question.
How wide does it move below your vanishing point? What is this?
What? Say that one more time.
How and why is it moving below your eye level where you claim you're complaining that with vanishing point? I take it, your eye level.
Yeah, because in reality, we have a finite vanishing point.
But no, I'm talking about the crossing of the plane of your visual horizon at eye level.
Right. Yeah, things that are above us and move away from us will eventually go below our eye level.
So
that's anti-perspective
on a flat plane.
That's contrary to the theory of the vanishing. That's contrary to what a vanishing point is.
No, it's not.
Yes, it is.
No,
it is true.
It is. It is actually contrary to what the definition.
What the contradiction is. Tell me what the contradiction is.
Because all lines of perspective meet at the vanishing point.
Yeah.
The vanishing point, any vanishing point, is infinitely far away. Nothing can start one side of a vanishing point and ever go through the vanishing point and come out the other side.
Yeah, but that's not how it works in reality. Things actually go below our eye level.
Exactly how it works. That is a definition of how perspective works in reality.
Below our eye level.
Can I say
that's
something?
How you guys have defined it because you think we live on a ball.
No, we're moving away from the subject.
There's a conversation going on. Hold on.
It's stupid.
Speaking to
we're moving away from the point of sunlight.
Hold on, dude. Hold on.
Co-show. You don't.
God damn it.
There is there's not one theoretical set of definitions of perspective and one real world set of definitions for perspective. There is only perspective.
Actually, there is still theoretical definition.
There isn't. You're just making shit up now.
That's why there's still optics papers that are written and ideas that are being discovered, and
there are no optic papers describing what you are trying to propose.
There are actually.
There are not.
Yeah,
there are. There just aren't. Because
it's read all the optics papers. So are you in the field or
cite them? I studied visual physics.
Are you an expert in the field?
Obviously, there's no optics that says we live on a flat plane.
Can you just cite it, Brandon? That would probably be the easiest way to tell.
No, I'm not going to get into this citing game.
If you're so sure.
Citing is not a game. It's a useful way in sharing information.
May I get back on the point of the sunlight? We diverted away from the sunlight because Brandon is diverting the subject away from the fact that sunlight.
We're talking about it still, Chris. He's giving his excuse for it.
I know, but here's the fact: in Argentina, in southern Argentina, it's daylight right now. Hold on. Let me finish this thought. In southern Argentina, it's daylight right now. In a place 6,100 miles north or 6,200 miles north, it's daylight also. How can the sun travel 6,100 miles, but or 6,200 miles, Brandon, and be daylight in all the way across that area? But if you go to northern Montana and go 6,100 miles north of that, so that you're in, let's say, southern Europe. Why isn't it light in southern Europe?
Is anyone going to mention Lail's mic popping or no? Because you guys bitch about percentage all the time.
It was, but Chris,
it's the same distance. 6,200 miles is 6,200 miles, no matter where it's at on the map. Why isn't it light? Why is it light in northern Montana, but not light in southern? Exactly the same latitude, longitude lines in southern Europe.
I'd have to look at the specific case that you're talking about, Lail.
Yeah, this was in context to the original thing. Now it's something totally different.
No, it's totally in context of the light on the earth and the sunshine.
Why don't we focus on observation?
The
sunlight traveling distance is the subject.
And Chris, you're to be commended. Great point, great question, and this will make for excellent discussion at some point later in the day. Thank you for bringing this up. And now Brandon's going to answer something, maybe.
I just want to point out a problem with having the vanishing point at a finite distance is that objects, if that was true, if the objects above your eye level went below the vanishing point at a finite distance, then objects below your altitude would have to be above your eye level at that same finite distance. And that doesn't happen.
Yeah,
that's a great point.
They go below the horizontal of your eye level, things that start off above it. We do see that in reality. Now, you'll tell me that that's because of curvature, but that does happen in reality.
Because of curvature.
Not because of perspective.
Yeah, that's what you say. It's because of curvature.
But the contradiction is that things that are below your altitude would have to go above your eye level past that vanishing point as well.
No.
Yeah, what you're saying, Brandon. What you're saying, Brandon,
is
the lines are
vanishing point. Wow. It works.
I think you guys are misinterpreting something that I'm saying, but
absolutely not. No.
I'm trying to understand what you're saying.
Absolutely, and not misunderstanding anything. We properly understand perspective, and you flat earthers have just butchered it for your own use.
No, that's incorrect.
Yes, it isn't incorrect. That is correct. We know how perspective works, and you don't.
No, that's incorrect. I'm telling you, that's not right.
I would really like to ask a very quick question on this point, which I think is pertinent to the matter. Toy, in your view, what's the major differences between things like the Rayleigh criteria and perspective? Because you seem to be crossing between those two camps, and I'm trying to understand why.
Yeah, perspective is that which causes the parallel lines to appear to converge. The Rayleigh criterion is just how the resolution of your eyes, right? How far you can see something of a particular size before it's no longer resolvable by your eyes, right?
So when you're talking about vanishing point, are you talking about an object being no longer resolvable, or are you talking about the converging of perspective?
I'm talking about the converging of perspective.
Okay, because that would be infinite, but obviously angular resolution has a distance-based limit based on the size of the object and the thing we're looking through.
Right. And now in your model, which is based on pure Euclidean geometry.
Don't know that it is, but...
Well, it is because you maybe.
I didn't think the Cartesian coordinate system was Euclidean, but I don't know. I'm not.
Yeah,
no, your model of perspective.
Neither one of those is actually how the world is laid out anyway. Those are two different interpretations of describing the world. You can look at it in many different geometries or coordinate systems or whatever. So it's not like one side of the world is non-Euclidean or something.
What I've been told a lot, this is the point I'm trying to get at, is that on a flat plane, you would be able to use trigonometry to triangulate objects in the distance, no matter how far away from you they get.
Mm-hmm.
Now, obviously, the result of that would be that it would take a very, very long time before anything would disappear into a vanishing point, right?
No. A fly will do it.
It would take
quickly.
a very long distance, not time. Distance.
A fly will do it quickly.
No, it'll never go down to 0 degrees in your model, right?
No, well, we'll lose angular resolution on a fly very, very quickly.
Yeah. Now, what we see happening in reality is that
Flies
things do
disappearing
move
very
below
quickly.
our vision. They do move below horizontal. So it all comes down to whether there's curvature or not.
Mm-hmm.
That's what it's all going to come back to.
And so the argument I've always heard for this from many people, including myself, is that the general refraction we get is a fraction of looming. And if the Earth was a flat plane, rather than looking at the fact that we might have a curve, or it looks like we have a curve, surely would get the opposite effect, and the actual horizon would be always slightly above eye line, except in very weird days. But it's not.
Well, that's what they say, but I believe that interpretation is based on, is based on an interpretation seen through the lens of refraction based on a globe model.
No, it's just refraction.
The effects of refraction have been defined within a globe model.
Yeah, but if we have refraction that is generally looming objects up, which I think you would agree on.
I
think so. I don't think you should give him any ideas.
Light traveling through a density gradient where the highest density is below bends downward. That's not up for debate.
So, for me, if it was the case that we're on some sort of flat plane and we're talking about refraction, I would expect at least to see sometimes, and generally reasonably frequently, the fact that the horizon would be above my eye line when I'm down at sea level. And I never see that. Never seen that in my life.
Okay. That's nice that you think that would happen. I understand.
That would have to happen.
I'm running a Feynman-like experiment. If the Earth is flat, what are the consequences?
I know you guys do this all the time. If the Earth was flat, this is how I think it would be. It's not that way, therefore the Earth's not flat. It's a logical fallacy.
Well, no, it means that the hypothesis that hypothesis we can rule out, and the more of them that we rule out, the less likely you have a flat plane, and the more we have what's actually observed from space, from land, through measurements, through all forms of testing, through huge amounts of congruency, that we do not live on a flat plane, but we live on a sphere.
Oh, I understand.
Something spherish.
Yeah, I get that.
I consider it to be a fact. I consider it to be a well-established fact, and I see a huge amount of evidence to back it up. You wanting to try and say it's a belief when I class it as knowledge because I can justify it, that's your poor logic and poor philosophy, not mine.
I would say the same thing right back to you in reverse.
Well, then justify it.
It is a fact that if I'm standing at the beach and sea level is 0, I'm 5 feet above sea level. My eyes are 5 feet above sea level.
Uh-huh.
And the defined definition for horizon is the apparent line where the sky and water meet. The water is still below my eye level. Always below my eye level, no matter how far in the distance you want to expand that 5 billion miles into the
distance,
Yeah.
the sea level is still below my eye level. Therefore, the
yes,
horizon
it is.
will always be below my eye level.
Agreed. That's exactly what we'd expect on a flat Earth.
Nope, that's what we expect on the globe Earth too.
Yeah.
But would you also expect that it drops further the higher you go on a flat plane?
Yes, I would.
Why would you expect that?
Well, if let's say the Earth is a parallel plane that extends for X distance, let's just say 50,000 miles. It doesn't matter how far it goes. When you rise above that surface, you are getting higher than that plane, correct? Why would you expect that view of the horizon, looking out over that parallel plane, to continue to rise with you when you're getting higher? Why would there be no change?
Infinitely far away would meet your eye level.
I mean, geometrically, it would get lower, obviously. But you're contending somehow visually it would continue to rise on a flat plane.
No, we've always said the horizon does not rise to eye level. I've never heard a person
the same way as if you look down a long corridor, it seems to all converge. Exactly the same principle. Next.
Well, it won't always rise to eye level. That's my point.
No, it doesn't,
horizon,
because the Earth's not
I don't
flat.
expect it to always rise to eye level.
It
I
will
don't
always
expect
not-
it to always rise to eye level on a flat
Okay.
plane.
Not
It doesn't make
ever
any sense.
rise to eye level is what I'm stating. On any shape of the Earth, it will never rise to eye level because your eye level is measured against the sea level, which is set as 0. Your eye level is always going to be above sea level.
Yeah, that's what I said.
Therefore, the horizon will always be below your eye level. Always. No matter what shape the Earth is, it'll always be below your eye level.
Why do you sound like you disagree with me, but you're saying the same thing that I said, pretty much?
Well, what about refraction, though?
I'm taking into account everything. 5 feet is always going to be above 0, no matter whether there's refraction or not. 5 feet is higher than 0 feet.
So are you saying that I can't observe looming that appears to be higher than me from my point of observation?
I'm just stating the surface of the water if we consider that.
Chris, Chris, mate, I think we got it. Come on, we don't need to get pedantic about this. We all got it. Come on.
Let's bring it back to this again.
The sunlight, but you guys again and purposely got
please, Chris. Please.
I'm really not, Whale. I'm not trying to ignore what you're saying. I'm really not.
We brought it back to yeah, we went all the way over here because we talked about the light and can the light reach this, and there's vanishing points and perspective, all that stuff. But still, none of this is an honest explanation for why the light on a flat plane, why the light can simply reach the plane, because you can see it clearly. So it's obviously reaching the camera. The camera's going to be lit because the sunlight is right there. But the sunlight is not reaching right beneath the plane where the clouds are, and almost the entirety of the clouds, all the way even much closer towards the sun. The sun's meant to be higher than the clouds, and it's not even lighting the clouds.
Okay,
So
I'll give you a reason.
This is a paradox.
I'll give you a reason. It's not a paradox. The altitude of the clouds is higher closer to the sun and lower directly under the plane. So the sunlight is getting blocked by those clouds. There you go.
That doesn't happen though. The sky's gonna be level.
Of course it happens. Are you saying that the cloud deck is always the same altitude everywhere on Earth, 6,000 miles away?
No, but just like water is level, the clouds are going to be level too.
The clouds are always level across the entire.
Well, the same clouds, the same air density. If it's changed, it'll be slightly changed. It's not going to be changed by some angling. As you get closer to the sun, it's going to be much. The angle's going to get much higher and higher, and the clouds have to be much higher. It's not going to happen like this.
Kosho, you don't know how high the plane is. You don't know how high the clouds are. You don't know the altitude of the clouds at the different points.
Bullshit.
There's really not.
I'm asking you to be honest. I'm asking you to be honest.
What kind of argument?
And I'm telling you, this makes perfect sense in my mind,
I
why
know you're saying
situation.
that.
If this was true, as the sun moved, wouldn't you see the clouds near it rising up to be above it? If you're saying it's an effect of the sun that has an effect on the altitude of the clouds.
Well, I'm not really putting that forward as a genuine reason. I was just pointing out that there's other possibilities, and you don't have enough data about this picture to really talk about it intelligently.
So it's just throw any old crap. It's just so your strategy here is to just throw any old crap into the mix in the hope that it can cast doubt on what we know to be true.
No, my strategy was to point out that you don't know anything about this picture. You don't have the specifics of this picture. That was my point.
Well, we know that what you proposed,
and you're interpreting it within your model, and then you're insisting that it is not possible in my model.
But we know that what you proposed isn't true, and even you agree with that.
Oh no, I don't. I do not agree.
Well, are you proposing it as an explanation or not? Because you just said you would.
It's possible. Can you rule that out?
Yes.
Wow.
It's never been observed. This doesn't happen. It's not how clouds behave.
For the reason I
At the end of the
stated.
day, if we're arguing about clouds, let's just ask the guy what he knows about clouds.
Wait, before clouds, I have a question. Since he agreed
what do you know about clouds?
Wait.
They're white, fluffy, and they taste like water.
Since he just agreed with Lael that the horizon will always be below your eye level because it's below you, the same logic, the sun should always be above your eye level. Why does it drop down below your eye?
No, see, that's the difference. In my model,
what's the difference
on a flat
here?
plane, objects can move below your eye level as they move away from you. Objects do move below your eye level as they move away from you because there's a finite vanishing point.
Wait. You just agreed that the horizon will always be below your eye level. Shouldn't it go above your eye level? Why should it drop?
It's always under
and the
you.
Sun. Yes, and the sun is always above you. And the sun is always, imagine the sun above you on a flat plane. Why is it dropping below you?
That space between the ground and the sun is getting smaller and smaller and smaller as it goes away from you.
And why is it
same as the Earth. Same as the Earth.
Down, down, down.
Same as the Earth. The Earth should rise then.
No, the Earth wouldn't rise. It doesn't make any sense.
What? Just the same way the sun drops, the Earth should rise.
Exactly.
And the whole point is they meet. No. They don't overtake each other.
We see the horizon. We see the horizon underneath our eye level. As that space gets smaller and smaller as things go away from us, things near it and become indistinguishable from that horizon, right? They'll go to the horizon. The horizon doesn't come up to them.
Except the sun. That doesn't get smaller, does it?
Right.
No,
why the sun? The sun should get. Why not?
So it's not behaving in a way in which you're
No, it's confusing vanishing point with perspective.
Yeah.
No, I'm not. I'm actually not.
And also,
no, I think you are. You know, like
I'm not though.
I mean, you've always. I mean, I think it's the same person. But you've been talking about, like, you know, the light can only go so far to get to your eyes, right?
Yeah.
But it only gets to your eyes because it gets there, right? That's why you see it. You know, like, so perspective is where, you know, just basically parallel lines seem to converge, right?
Yeah,
but
that's part of it.
You cannot use that for the sun or its setting or any angle of attack or anything like that. Like, you know, why does the sun sit below the horizon? Like, you know, that's, you know, we're banging on about shit, but you haven't explained why, like, a full sun can sit below the horizon over the ocean.
They're very simply, like I said, perspective.
Below eye level.
Yeah, perspective would dictate that the sun is getting smaller, and this is the only reason why it would be getting.
But it doesn't.
I know. I'm done. This is Brendan. Very quickly.
There are
also how the light rays get to your eyes depends on how the light passes through the density gradient in the atmosphere. Don't forget about that, guys.
That sounds like a load of bullshit.
Yeah. Hold on, guys.
How is that bullshit?
They get to your eyes because they get to your eyes. You know,
but they still have to pass through the density gradient in the atmosphere. The light rays still have to pass through the density gradient before they get to your eyes.
You're right about that. Very quickly, just very quickly, because as people keep saying a bunch of different stuff, so address that very quickly. Babs, it makes no sense if you think about the plane, the sun that's above the plane. So the sun's above the plane's above the clouds. The density from the light to the plane, okay, and the density from the sun to the clouds, it's never going to be in that lower density place on a flat plane.
Right. I wasn't talking about the sun in particular. I was just talking about light rays in general.
Okay, but
that's why when we look at
move on to that, Babs. But
we're
trying to.
Really, you're just gonna cut me off like that?
Yes, because you're cutting off what's going on with Brandon at the moment. We can do what you're talking about.
All right, carry on.
I just said though, Brandon, about the density. It doesn't make sense that that's a mechanism for what you're talking about, and the perspective.
It does. It does make sense.
So listen to what I just said and be honest.
No, I heard you.
Well, then that makes sense of it because the density is below the clouds, and the clouds are below the plane, and the plane's below the sun.
Respond. First of all, how much of that light is getting to the plane?
Enough
yes,
to see
the sun.
No.
Could you not see the sun when you're standing at the clouds, because it's not completely dark on the clouds?
Let's just reel it back.
Is it?
If you see the sunlight, if someone were looking at that camera, they would see the sun shining on the camera. That's how.
If you were standing on those clouds, you would still be able to see the sun.
Sorry, Kosho, but I just need to ask a question because these guys like to be so smart.
Yeah, I know,
what causes clouds? You know, if the issue is the clouds,
please. Rich.
What causes clouds?
No.
No, there's not that many syllables.
There's no cause. There are no clouds. Now, why does the sun cross your eye level?
Yeah. Well, I just want to ask a question. What causes clouds?
The sun. Sun causes clouds. What causes the sun to cross eye level? There's no coherent, rational, logical explanation for this.
Yeah, I know. I'm just beating a dead
horse. Brandon, show us what you don't know, man. Explain.
Tell me what causes clouds to form.
I'm sorry you didn't understand it.
Tell me what causes clouds to form.
So who here understands Brandon's explanation? He's making it out as though I don't understand it, but it should be understood. Who gets what Brandon is saying as to why the sun should cross eye level?
I don't get it.
No, it doesn't happen.
Yeah. That would mean that you should see Earth above the horizon then.
Yep.
No.
What is he?
That's silly.
What does he mean by that?
Think about it for a little
It is
while.
silly. It is silly. It is silly. Yeah.
Because it's wrong.
Sometimes have trouble thinking in 3D.
Brandon,
so maybe if you think about it and model it,
you go uninterrupted. It doesn't make sense in any mechanism we know of, but it makes sense to you. We're gonna let you speak uninterrupted if you shed some light on this subject. If you don't know, then you say you don't know. But
well, what is the question? Because there's been like 5 questions.
Yeah, I dare you to model it. Go ahead.
Dare you to actually use the rules of perspective as they've been set down in reference books, instead of this corrupt abortion of the rules that you've adopted.
You've adopted a corrupt abortion because you base your rules on the Earth being a ball. So you had curvature.
No, the rules of perspective are completely independent of the shape of the Earth. All the rules of perspective do is show you how and how much the Earth is curved.
Wow, that's not biased at all, is it?
So yeah, Curve's question that you said that we have to look up or something. That's the one that that's the question that we're talking about. Why would the sun over like Bazaar saying, why when perspective says that things are converging when they get smaller at some infinite distance, why would it overtake, like why would the top of an object overtake the bottom of an object, or an object above your eye line overtake something below your eye line, like the horizon?
Well, here's the thing, there's atmospheric effects. The horizon you're seeing is not the actual horizon. In almost all cases, right? I can't pinpoint one where I would say, no, that's the real horizon. There are atmospheric effects that take place above the horizon that can actually block you from seeing something that would be otherwise directly in your line of sight.
How convenient.
Well, it's true. We've observed it.
That's fine. But just remember what the question was, because before you say something that someone's going to pounce on it. The question of why would something above something overtake something below it?
Yeah, just did. I just answered it.
Well, no, you said, just there's atmospheric effects, and sometimes the horizon's not always in the place that it looks like it is, and things could be behind it, or stuff like that. But
Obviously,
that doesn't say why the sun
that light
would go below
travels
your eye line.
straight is what's under contention.
You know that?
Right. Obviously, light bends.
Exactly.
Should it go in both directions? I mean, does it go left, right, and up and down? All going to the vanishing point?
Well, the thing is, when you're seeing the sunset or the sunrise, it's so far away that even though the air, the things going on, the temperature is heterogeneous between you and that 6,000 miles away or whatever, on that scale, it's in our scale that we're viewing it on, it might as well be homogeneous circle around you. You understand what I'm saying?
No. Is the sun 6,000 miles away?
Well, I don't know exactly how far it is. I'm just saying, if the sun's above point A and it's sunset in point B, roughly 6,000 miles away, something like that, right?
Okay. If that were indeed true, then you've got some serious problems.
Just using a number as a placeholder because I'm not looking at a map. You know what I'm saying, right?
I know that. The spot over land that's at sunrise and sunset, the spot on the land that the sun is directly above is going to be about 6,200 miles away from you. 62, 63, refraction, all that kind of stuff. It's in that range. It's a good enough approximation to work with. And it's consistent. Now, what elevation do you want to put the sun at?
Oh, I have no idea. I don't know.
Why not?
Because I haven't
Why
been
can't
able to
you?
calculate it. I haven't been able to measure it. I don't know the answer.
Well, you do, because you just said it will be on the horizon.
And you told me the sun is so far away. Without apparently knowing how far away it is, you told me it's so far away, but you can't even put a guess on it.
All right, first of all,
you want me to guess whatever? Let's see if it's. I mean, I could. Yeah,
just to give us an idea of what world you're living in.
Let me see here. What's 55. What's the square root of 55?
Square root of 55? Hold on a second.
Yeah, square root of 55.
Flat Earth model, let's just say it's convenient to say that light bends at your convenience. If you just say that, then you're clear.
I don't have the square root function on my calculator.
Let's say it's between 4 and 8,000 miles above the surface of the Earth, just for the sake of the conversation.
And why in the hell is it at the horizon at that distance to the subsolar point?
Well, it's not actually at the horizon. It just appears that way.
Yeah, it's perspective. You know that.
No. Perspective puts it well above 26 degrees high.
No, that's your janky model.
No, that's what you just said.
Your model is janky.
This is what you just said to me. You'd put it at 4,000 to 8,000 miles. That is well over 26 degrees above the horizon, son, what you just gave me.
You can't calculate
Your
that.
estimation, if what you just estimated had any basis in reality, perspective has it at well above. We can do the math. You could do it right now. If the sun, Brandon, if the sun were 6,200 miles away and straight up, over the land, 6,200 over your flat Earth, and straight up, you got a right triangle. Give me the distance to the sun and the angle of elevation above a flat plane with a sun that's 4,000 miles up above a point 6,200 miles away from you. You certainly know how to figure that.
That's why I gave you a range. Because
and let's go with the minimum. Let's go with the minimum.
No, you told me not to interrupt you.
Angle of elevation and distance to it.
I told
using
you
4,000 miles above.
Listen to me. You can't apply that trigonometry to those kind of site observations. It doesn't work like that.
Why? You said it's perspective.
Error compounds over distance.
Perspective is trigonometry, you twat.
No, it's not.
You tell me you can apply it to it.
No, that's your janky model where you add the curvature to make it work.
No. Go ahead and squirm, but no.
Your shit's janky.
I'm not squirming. Bondo on that shit.
Curve's not bringing up the globe at all. He's not bringing up any curve at all. He's bringing up only perspective. That's what he's talking about. He's talking about the perspective that you're describing and what it would actually
talking about your flat model.
It's not.
On your flat idea, conception, fantasy, whatever you want to call it. 6,200 miles on the ground. Go straight up 4,000 miles, your minimum that you estimated, and let's see what angle of elevation that gives us in your distance to the sun.
How many times do I have to say you can't?
How many degrees up is that?
You can't calculate it like that.
That's perspective. That's perspective, Brandon.
Those site angles. No, it's not.
Brandon, that's perspective.
It works in short distances, but after.
What do you not get about that? That's perspective, Brandon.
Prove it. Prove that it works at those long distances.
That is perspective.
Make a flat line.
If you want to bring atmosphere into it to alter it, we can do that next.
I'm not bringing atmosphere, and I'm saying.
But why are you afraid to do this, Brandon?
You can't apply that calculation. It's a misapplication of trigonometry to calculate long distance site angles like that.
Yeah, somebody else back me up. I'm tired of arguing with this prick.
You have nothing to back it up.
Why can't you understand this?
When you're specifically saying that it's not on a globe, it's not round, and then you don't have to worry about the atmosphere. There's not any reason whatsoever that you cannot use trigonometry or triangles or anything to describe something on a flat plane, an object in the sky, and the angles and distances between them. There's nothing at all that is counting that.
Yeah, it is. That's how perspective works on a flat plane at long distance. That's how it works.
Exactly. It works using trigonometry. Yeah.
It doesn't work. It doesn't work with trigonometry. It doesn't work with trigonometry. You can't do that.
Why?
What do you mean, why? Why would it? Prove that it does. Show me something 1,000 miles.
Perspective is...
For short distances, using trigonometry like that will get you a good enough answer. Accurate answer.
What point does perspective change from being accurate? Because you can look at the angular size of something at a distance and determine how big it is.
I wouldn't use that and expect to be accurate down to, say, the inch.
No, we're not looking for inches. We're dealing with thousands of miles here. So go ahead.
Yeah, the error increases. It increases exponentially with the distance.
Error, like when you said the error increases, why is there error at all?
Because it's a misapplication of trigonometry when you apply it to long distance site angles like that. So there's error.
Misapplication.
Is it closer to the edge?
Such great skill.
Hang on. Brandon, does a lack of trigonometry apply when you're closer to the edge of the plane, the world, as opposed to being closer to the center? Like, is that why you're saying it doesn't apply? Because you're referencing it when you're closer to the edge of the quarter? Quarter, I mean like a coin, than the center?
No.
Is there any difference when you're closer to the edge? Is there any close? Does it change? No, it doesn't change when you're closer. So it's the same obscure trigonometry falls apart when you're in the center as opposed to when you're closer to the edge. Okay, just clearing that up. Back
Well,
to the
I
air
mean,
conversation.
you can go outside and test it yourself. You can go outside and test it yourself. Do it with, I don't know, a building like 10 miles away, and take your sight angle to the top of that building and use trigonometry to try to calculate the distance based on the height, and it won't work out for you.
You can use parallax.
I can measure the height.
B-baller for life. He made a video about you, but he made a video where he did exactly this.
Yeah, he did it on a basketball court at that distance. The
Yeah.
error is so small, it doesn't even matter.
There's not error.
He only got within like, he was still like centimeters off or something like that anyway.
You're inventing an error that doesn't exist.
No, it is error. There is error. Go outside and try it. You have a tall building like about 10 miles away from you or something, try it.
But what happens if I'm within 5 miles of the edge of the Earth? Then does it work? If that extra 5 miles is off the edge, or
why would the edge of the Earth make any difference? I don't understand.
No, because at the edge there's different things.
No, I don't think you're bringing in a variable that I don't think has any impact on it.
Can I ask a quick question?
Anything to do with flat Earth, like the edge, has nothing to do with flat Earth. Right?
Well,
I
we
love
don't know
this.
if
I love
there's
how
an edge.
every
That's
flat
the
Earth or
problem.
anywhere on the flat Earth never approximates their distance to the
Your
edge.
script's old, bro.
What
Your script's old. It's an old script. Get off of that.
Let's not take it somewhere else.
Brandon, can I ask a question?
Of course.
Where did you come up with the or from where did you get the idea of 48,000 miles for the height?
48,000 miles.
Yeah, for the height of the sun.
It was just a guess I pulled out of my ass. I said, okay, if you could use trigonometry, it would be like 7.5, but we know you can't. So I said, well, let me make a guess. I'll just give a range just for the sake of the conversation and say
So it could be 93 million miles still.
No, it couldn't be that far. No.
Well, what about? Hold on, Brandon. I don't know if Curved has brought up the issues with the speed of the subsolar point and the radius of the subsolar.
Right now.
Oh, okay.
Because guys, there's a lot of people in here. And,
I'll let you guys go then.
No.
You guys are doing a great job.
Simple trick. Yeah, we just want to keep it on the one path. That way, it doesn't get diverted and he runs off without getting any conclusion. That's probably not gonna happen anyway.
Well, it's definitely going to happen. We're not going to come to a conclusion today, and we all know that.
Yeah, but it becomes pointless if we go in a million different directions. So,
Are you telling me we're not going to settle this whole thing today, Brandon?
Well, there's always a possibility, but I wouldn't bet on it. I wouldn't put your life savings on it.
There's two things that are in contention now, but the most recent one is the trig one. For some reason, it doesn't work. There's errors in it for some reason, which you haven't stated.
Well, why would it work? I mean, it's a misapplication in the first place. You guys just think it would work, but then you add this curvature to it. So you can't use it like that.
Why not?
It gives you the fucking answer that the Earth is a
Give me
globe.
some experimental evidence that you can at long distance. Like I said, go outside and try it for a building 10 miles away. You go find yourself a flat plane and prove that it wouldn't work for long distance, or that it would. It wouldn't work.
Oh, are you trying to rely on the curvature of the Earth to give that error?
That's what it sounds like to me.
You are adding what you think the curvature is to contend that it does work. That's what you're doing.
No, not if we were talking about trigonometry.
No,
we're not adding in anything. No. We weren't adding in anything. We were talking about the actual trigonometry of why you would be going over a flat plane to look at that building that's 10 miles away, and why the trigonometry would be wrong.
Because
that's what we were looking at, right?
Distance sight angles like that, because of perspective,
why?
The error compounds over distance. That's just what happens in reality.
Why?
Because that's how our vision works.
So it's based on our vision?
Yes.
So
of
if
course.
we get
That's
something, if we get something that enhances our vision, if we get something that enhances our vision, right? Say like a telescope that we can see further.
No, because it doesn't matter what the sensor is. The optics work the same. We're not talking about the specific sensor or resolution. We're just talking about the nature of how the world presents itself to a single point of view.
Right, exactly. So if we can change that optical view, right, by enhancing it, that is going to change what our limitations are. It's the same as your perspective. Hold on. It's the same as your perspective. Okay, you had a vanishing point with your eyes. Now you get a set of binoculars. That vanishing point is further. So then you get a telescope. That vanishing point is even further, right?
No, the vanishing point is never further. You're confusing two different concepts. I'm not talking about the Rayleigh criteria.
I'm not talking about the Rayleigh criteria either.
Vanishing point. So if you had a building that was 100 feet high and say 50 feet from you, and you had another building the same exact size on a level plane that was 100 miles from you, and you drew a line down the top of the building towards the other building, where that line terminates, that's the vanishing point.
I think you're misunderstanding how that vanishing point actually works.
Well, I'm not.
Are you? See, because while I was going into my explanation, I used vanishing point twice, right? Talking about the distance that we were measuring. You said that we couldn't do that because it was the limitations from our eyes. So I enhanced that vision by getting a set of binoculars.
No,
we were talking
about
change the distance,
when we
right?
talked about the limitations of when you're mixing two conversations together.
No. You're mixing
Previously,
two
we were talking
conversations.
about vanishing points. Now we're talking about why you can't apply trigonometry. And when I said that it is how we see the world, it's optics, you brought in limitations. I never used the word limitations.
You're the one that said this shit,
Doesn't have
Brandon.
anything to do with limitations. In regards to how the world looks to you, there are no when we're not talking about limitations. We're
Fucking
talking
dishonest
about
piece of shit, Brandon.
It's so much doublespeak at this point.
Why did you just call me a dishonest piece of shit?
Because you literally said it's the limitations of our eyes that prevent us from being able to use trigonometry, and then one sentence ago you said that no, that's not what I'm saying. That's why you're a dishonest piece of shit, because you're fucking changing your argument because it doesn't work. Because you know it doesn't work because you're a fucking liar.
You fucking asshole. Let me clarify, because if I did say that, then I confused the two conversations. When I'm talking about...
So you're just confused about how optics work then?
No, I'm not. You guys are interrupting me every 2 minutes. And we're having two different conversations. So I really can't fucking get it out.
Pick one Glober. Just pick one Glober.
It's not, that one has to pick.
No, that is what it is.
Jeremy, stop. Just everyone in the room just has to be more respectful, and if you do what he's just said that everyone's doing is interrupting him and all this other stuff, you're gonna give him a chance. You're gonna give him an out. There's no need to give him an out.
Okay, just pick one Glober. Pick one. He doesn't need an out. He's right.
Jeremy,
You don't need an out.
Pick one Glober. Jeremy, shut the fuck up, Jeremy.
Well, that's why shit's getting confusing.
Shut the fuck up, bitch.
Okay, loves you.
Are you guys afraid of what Brandon has to say? Is that why you keep cutting him off?
Yes,
not at all. Hold on.
He says no need to bring it up.
Can we go back? We can have a conversation either about perspective or limitations. Which one would you like there, Brandon?
Well, let's talk about perspective, since that's
okay. So let's go with perspective.
Our ability to use the trigonometry. That's what causes it not to work over long distance.
So it's our perspective, right?
Yeah, that's how we see the world. It's how the world presents to a viewer.
Right. So we're talking about as a person, right?
It doesn't matter if you're as a person, a camera, it doesn't matter. There's no enhancing that will change how the world presents to a single point of view. You can, you can
hold on there. We're at a disagreement already.
But let's just, okay, if you want to just talk about a human or a camera sensor, that's fine. There's no sensor that you're going to be able to create that will cause the trigonometry to work like you want to use it.
Well, no, I'm agreeing with you. That trigonometry will not work.
Yeah. Okay.
Okay. But why? That's the big question. Why?
Yeah, exactly what I said about 45 minutes ago.
Yeah, and we have
guys.
Do you mind me asking me a question?
Let this guy finish. Let him at least finish up what he's saying. Yeah.
So the reason. Okay. The reason that we say that the trigonometry is not going to work is because of the Earth curvature. But what is the reason that you are Okay, so what is the reason that you are saying that the trigonometry is not working?
I'm glad you're catching up. The reason that I say that that it's not going to work is it is a misapplication in the first place. You can't use trigonometry for long distance height measurements the way you're trying to apply it. It's only accurate at short distances. When you try to use it at long distances, you will not get the trigonometric answer. It won't match reality.
So okay, hold on. So we can't use trigonometry when we are determining an angle to any place, is what you're saying on long distances?
The longer the distance, the more it will be off.
Yeah, I'll agree with you on that. I'll agree with you on that. There is a room of error, right? It's the same as if you're building something. You know, like if you're building a house, you have a room for error in that house. You know, you can go and say that this is a 90-degree corner, but really, in all honesty, it's not really a 90-degree corner. It's a 90.5-degree corner.
I'm not so much talking about margin of error as I am a error that compounds exponentially with distance.
Exponentially as well?
Guys, let this guy just get to his thing.
It still has a,
if you want.
it's still going to be a margin of error. At the longer the distance, the larger the margin of error, right?
Yeah.
Okay, so we're in agreement that you can still use you can still use trigonometry to measure things at long distances.
Then you have to add the offset for the error.
Yeah,
okay,
I think the main point is that you're saying that the error is caused because of the curvature of the Earth, and Brendan hasn't given a reason why there's an error.
Right.
Well, I have. That's just, you haven't substantiated that you can use that for long distance site observations like that. You haven't established that at all. You're saying that you should be able to, or at least some people are saying that that's how it should work on a flat plane, but we don't have any evidence to substantiate that. Now at short distances and on paper, obviously trigonometry works pretty well, but long distance site angle observations like that, you're going to get the wrong answer, period.
Now we just need the reason why. We have a reason why, so we don't have to say magic or we don't know. So we're asking you what the reason why is on your idea of the Earth, because on our idea of the Earth, that's the reason why there's an error.
That's what I'm telling you. I don't need a reason why, because you have never provided a reason why it will work. You just say it will work.
He just said to you that we get errors on the globe Earth because the globe Earth is curved.
No,
that was the explanation. Yes, that was the explanation. That's why we talked about the margin of error, right?
Right.
And also why the trigonometry does not work, as in you have to add in other calculations to it to get that distance.
And that's why
previous to that, we were going off of straight trigonometry.
Okay, well now my interrogation question to clarify this. Brandon, do you mean like if you're trying to find the height of a building that's 10 miles away and you hold up your hand in front of you and your hand's moving a little bit and you're trying to like measure that building with just your fingertips, like the bottom of my index finger and the top of my thumb, a little squishy there, that it looks like 1 centimeter. And so I think I walked 10 miles away from it. So 10 squared plus whatever I think that is, right? And then you begin your trigonometry calculation to figure out, a squared plus b squared equals c squared. And are you just saying because the way your hand is held measuring the thing at a centimeter, because your fingers are a little janky and you're not certain how far your one eye open peeking through your fingertips is a little janky, that's where the mismeasurement comes in? Is that what you mean by it's unmeasurable, is the way a human can measure?
No. I'm not saying it's not measurable.
Now,
obviously,
did you graduate
measure
from
an angle?
junior high?
You can use like a oh, I see where you're going with this. This is just a joke to you. So what I'm saying is more like you're using a what are those things sailors use? I have one in my house. Yeah, a sextant. You're using a sextant, and you're measuring the angle to a top of a building 10 miles away. You take that angle, you know the distance, and you say, okay, the angle's this, the distance is this. Now I can calculate how tall the building is. That won't work.
And exactly why won't that work? Beyond a
Why
margin of
would
error,
it
why
work?
won't?
Why would you
Because
think
it's
that you
well,
can
it's a
apply?
tool that
Why would you
sailors
think
use.
that you can apply straight trigonometry to a perspective-based sight angle measurement? Why would you think you could do
What is
that?
that?
And
What
where
was
have
that
you
tool called
validated that you can do that on a flat
you?
plane at distance?
Right. Well, wait, you just said sailors use this tool, so someone invented the tool for a reason, and whatever that reason is why I would use it.
It works at
Cause
maximum
and
distance
effect.
too.
Sailors work on a cause and effect relationship. I moved this far. The star moved this far. I know where I am here. You map that out. It's a predictable relationship between how high the angle is in the sky and how far away you are from it. That does not substantiate whether we're on a flat plane or a globe unless you assume that's trigonometry based, which it's not.
That's not what we're saying, and that is it gives you an angle to the elevation of the object.
You place this on a globe.
If the Earth were flat, then and you knew the angular elevation of the object and the distance that it was, like the top of a building or whatever the hell it is, you should be able to know. You should be able to easily determine the height of that object.
That's what you say, but that's what you say. That's your contention that you would. Be
I know,
able to
but
do
now
that
you need to give a reason why that doesn't work.
I don't need to give a reason that it doesn't work. You need to provide experimental evidence over long distance on a flat plane that it would work that way. You need to substantiate that it would work that way. It's your straw man to say that it should work that way on a flat plane. It's not a straw man.
No. That's not a straw man.
That would work.
That's trigonometry. That's not a straw man.
You cannot.
That's what we were on.
Trigonometry like that to long distance sight angles. How many times do I have to say it before
You
guys
keep saying that, but
position?
you haven't provided any evidence to prove otherwise.
Go outside, find a building 10 miles away, and try it.
Yeah, and it's not going to work. Do you know why?
Yes,
why?
Because it doesn't work.
Why?
Because
why doesn't it work? So you don't care why you don't care why it happens. You just know that it happens, and you're just going to assume that it's not because of Earth curvature. That's what you're saying.
Assume that it is an Earth curvature, and that's how you've represented the relationship
Kosho, check your PM.
Sight angles or the celestial objects. You've insisted for hundreds of years that it's because we live on a giant ball, and that's how you've represented it. That's how you represented it in your model. That does not mean it's reality.
So the reason why that they had to add in those calculations to account for the Earth curvature was because the trigonometry didn't work.
Shit.
Because they went out and tried this. So, your explanation is that it doesn't work, but it's not Earth curvature. That's the only explanation you've given so far. So, what is the explanation?
Holy fuck, how many times do I have to fucking tell you?
On a flat Earth, it should work. The curvature we're not using. So
based on what?
No.
Well, hold on. It's very
Based on
simple.
the first plane being flat.
I understand
That's why it
your
should
position.
work.
You're trying to apply
No, I'm using the flat Earth model.
one-to-one to these sight angles, and you're saying
Not
trigonometry should
one-to-one.
work.
I'm saying there's an error.
We find in reality is it doesn't work.
Yeah, try not to interrupt, but yeah, it's not difficult. It's mathematics, man. So it's geometry, trigonometry, numbers. Whenever you get past 1,000, it's a big number. Million's a big number. We don't assume that they start doing weirder stuff and we get higher numbers. That's consistent the way we set them up. Geometry, trigonometry. There's not some scale in which they don't work anymore. Like these things work. These things work at scale.
It's a misapplication, Kosho.
It's not. You have to explain how that. You have to explain why that is.
Apply Euclidean geometry to long distance perspective based measurements, sight angles. You're mixing two things together and then going, it doesn't work.
Why? That I'm agreeing with you. It doesn't work. Why?
Nothing else I can say to try to get you guys to understand my position.
Yeah, there's nothing you've been saying that actually explains it. You've offered no explanation.
Hey, Brandon, I'm glad you're talking about this because I'm literally making a video about this right now.
Oh boy,
Literally,
I'm excited.
wow, amazing.
Looking forward to that. You proved a lot with your basketball hoop 10 feet away.
Hey, exactly this point.
Brent, I just want to
No,
say that I
that's your point.
sincerely
That's
believe
your
that
contention.
your best argument would be to say that light itself is janky and that it bends weird and that the held model of light is itself janky. And I think you'd be better off arguing your position if you just started with that broken premise.
No, you wouldn't. You wouldn't because
Yeah,
I'm
you
not
would.
going
I
to.
think
No,
you
I'm
totally
not
would.
going to
Because,
try to guess
well,
like you
I'll
guys
just
and come up
say,
with a
listening to you
story
for an
for
hour.
why it doesn't work.
Mr. Lucky Me,
I don't
you
make
can't
stories
interrupt
up.
that.
We
I
don't
don't give
do
a
that.
fuck
We try
whether or
not to
not
do
you guys
that in
appeal to me
Flatler
or not.
to make
I know, but
little
you can't interrupt
stories
like that.
up to explain everything.
I'm not fuck
I couldn't
you,
hear
buddy.
either.
I'll
I couldn't
interrupt
hear
if I
either
fucking
one.
want.
No, you won't.
Well, mute me.
Well, no, just be respectful, man. There's a lot of people in here, and so they're probably gonna want a chance to speak too. But so definitely just don't talk over the other people. But
I'm done.
Well, all I was saying
Sure.
to exhale for 15 seconds was to say the part where, because I think I saw the photo of the mountain and the shadow on the underside of the cloud, and then when he was asked, after the discussion about being 5 foot above the sea level, and then he argued that somehow the sun could fall below that 5 feet. Well, he didn't say that particularly, but below the level of the clouds, and that somehow he just, word twisted the idea that the light and the perspective and whatnot doesn't work that way when it's at a distance, hence allowing the sun to look like it's below the clouds, shooting light upward now, and on a flat Earth model. At that point, I was left with, okay, well, that if that is his argument, he's best to say that light just warps, bends, or refracts, or doesn't go straight. So let's annihilate that, all you straight lighters out there, right? And so that photo does appear to me to be that the sun has fallen below a circle and is shining upward on the clouds, and it does seem like a natural evidencing of the curvature of the world. So I'll just say that the dogmatic argument, the fact that I'm even in this room, seems like an entire waste of time. But good morning to you all. Thank you.
Well, I think you're basically correct that it's better to claim a physical property of light that we don't know about and have never seen than to make an obviously fallacious argument.
Obviously fallacious, huh?
Yeah.
I'm done.
Yeah.
What's your
Roger.
evidence that it's obviously fallacious, Brendan?
Well,
it's not obviously fallacious.
the principles of mathematics are flawed or whatever.
No, it's a misapplication of mathematics. If you misapply mathematics, why do you expect to get the answer that you would otherwise? You're misapplying it.
Yeah.
How? Okay, so again, because it's a sphere, I agree with you that you wouldn't be able to make an observation like this on a sphere. On a flat, if the Earth were a flat plane, you should be able to use a sextant, determine the elevation of an object, know the distance that it is from you, and using that, be able to simply determine the height of this object. Because
do you see what you're coming back to?
There's no reason for trigonometry not to work.
Do you see what you're coming back to, though? You're coming back to your base premises we're on a sphere. That's what you're coming back to.
That's why I'm saying I agree that it doesn't work the same way as Soroku was saying. Because I agree that you can't do this. So there's not going to be something you're going to be able to do because of the fact we're on a sphere.
No,
now, that's our reason. That's our reason it doesn't work.
No,
So,
I know it is.
No,
That's
the base premise.
The key misunderstanding. That's like the original sin is this misunderstanding.
It's not really that misunderstanding is as if you're not really understanding any shit, man. Because they're telling you use trigonometry. Hold on, I'm speaking. They're basically telling you to use trigonometry to discover like the distance or the the elevation of the sun. Like whenever you're under the sun directly, you can use trigonometry with another guy taking a different angle from a different position, and you can get the distance between you and him. You can measure that tangibly if you wish to. You can then get some information for where the sun is actually, but you can't do it because we're on a globe.
Can't do it because that's not how it works on a flat plane.
So
this doesn't work for that
Dude, listen, you can put a table, you can eliminate a bolt on it, you can use trigonometry, you can do it. Why does it work on a flat plane then? What's the difference?
Short distances, it doesn't matter. It just doesn't work over long distance.
Even long distances, if we have a higher margin of error, we at least can get a gist of how far the sun is. We don't need to know exactly where it is or how far it is. We can get a feeling with the thing in millions, in thousands, in billions of meters. Who knows? We need to get an estimation. That's all what we care of. But yet you can't do that.
No, because on your model, you got us out at 93 million miles. The sun is obviously not 93 million miles away.
You say
So
obviously.
Your error
You say obviously. Do you have an evidence? Do you have an evidence?
Yes. Common sense.
That's not evidence.
We don't use common sense, motherfucker.
I don't give a fuck.
You just try not to.
Well, basically,
I'm riding a fucking pink unicorn.
That's just.
On a pizza plane.
Oh my god.
Nice guy. Just be smart, man.
So the base premise is that trigonometry works. It's not assuming the globe. It's simply assuming that mathematical truths are in fact truth, which they are.
Wrong.
No. Yes. No. I'm correct.
Your base assumption is that you can apply the trigonometry to long distance perspective based sight angle observations. That's what your base premise is.
No. I'm assuming that trigonometry is true.
Well, that's a dumb assumption.
Well, Brendan, what about short angle measurements, and then slowly after a short term measurement, then you back away and you make it a long term measurement. You do it incrementally until you see the margin of error. Like if you walk up to a building and you measure its height and you measure your distance and you measure the angles, right, and then you slowly back away and you do it again and you do it again and you do it again until that point where you think that it's off. You could journal that, right, and index that it's off, but the trigonometry itself is not off. Like you said, the application world
he thinks it is off.
It a little worse. The application.
He thinks it is off.
Wait, exactly what you just explained about taking an angle of something as you back away is exactly what I'm doing in my video. Be on the lookout for that.
Where do you find a flat plane long enough to experimentally prove that it works at long distances on a flat plane? Because that's what the contention is.
It doesn't matter.
Yeah, but you're just saying long distance.
So what are you exactly are you saying?
He's saying that trigonometry doesn't work for large triangles.
Yeah, that's exactly.
No,
what the question
Why
is.
wouldn't it work for large
That's
triangles?
not what I'm saying, Brendan.
Brendan,
Fucking bitch.
Brendan, I want you to be clear that this is what everyone is hearing. So in a second, just clarify what exactly the issue is, because if the Earth is a flat plane, just like a small basketball court or the large Earth, doesn't matter. If you use something like a sextant and know the distance to the object, then you're just describing a triangle. There's no reason why the triangle is not a triangle anymore. So
because we do not see in Euclidean geometry like that. Our perspective, the way the world presents it to a single viewer, skews that relationship that you rely on for trigonometry.
That's wrong. That's wrong.
So you don't think that we'd be able to measure? Let's say if I'm trying to measure a building, you don't think I'd be able to measure that building without physically measuring it?
Well, I'm not saying there isn't some way you could do it, but at long distances, just using trigonometry, no, I don't think you could do it.
You don't think so?
That's Brendan. No. That's your escape hatch. You just import the word long distance. So a short distance it'll work, but as some unparticular, undefined thing, you'll insert the word long and say then it doesn't, and that's convenient.
That's what you guys do locally.
No,
level.
So Brandon,
hey, have you ever heard of locally?
Brandon, if I measure, if I use trigonometry to measure a building from 3 miles away, right?
Yeah.
And then I find out exactly how tall that building is, and it's within a few feet. Is that not proving that we can measure things from a distance?
No, it's only a few feet of error expected at that distance.
Yeah, that's not how trigonometry works. Trigonometry doesn't work depending on on the scale of the triangles. It works for all triangles, regardless of size.
Let me just conclude, and I'll address what Brenda said for the last time, because I have to get off. So I am not contending that trigonometry doesn't work. I know trigonometry works on paper. And you can use trigonometry with side angles at short distances with very good accuracy and decreasing accuracy the longer away from you the object that you're measuring is. What I'm contending is that it's a misapplication of trigonometry to perspective-based sight angles. You are mixing your maths. You're mixing, it'd be like mixing spherical math with planar math.
So it's based on sight angles. Angles are part of Angles are part of trigonometry, dude.
Oh my God! No
Brandon,
shit.
what you need to do.
You said it's invalid because it's based on sight angles, but angles are part of trigonometry.
There was some other words there. You go think about it, Brenda, because we're not gonna sit here.
Well,
there's
one slight issue with what you keep saying, which is the perspective. You keep throwing perspective into it, and that has nothing to do with the angles. All right, we're only taking the measurements, regardless of what you're looking at. You're taking a measurement from you to the building, and and coming up with your angles. So it's not a matter of perspective at that point. It's a matter of distance.
Can you look at the world without perspective coming into play? Show me how to do that.
Use a sextant.
No, that's not it. You're still vision based.
Again, it doesn't matter if you're taking a distance measurement from one place to the other place, right? So
think about
hold on, Brandon. Hold on, Brandon. Okay, I'm going to put this into perspective. This is good. This is only going to take a second. You're standing there looking at the building.
Run away. Go ahead. Run away. Run away.
Don't do that, Brandon.
I've been here for an hour.
Run away. Run away.
Jesus Christ.
You know, Brenda. Oh.
So Brandon, we'll have this conversation later. All right.
Well, I have a show from 5 to 8 on Brandon's channel. You can find it on YouTube.
I can find me your server.
Yeah. Go ahead. Come on over anytime. You can join the show and we can discuss it live.
In the meantime, run away, Brandon.
Yeah, dump out of
I'm gonna run away now.
Are you running away?
Guys, he's
You wearing running shoes, Brandon?
He wasn't answering before he left. He's not answering. He's not running away just not to answer. I think that.
And if I could find Bigfoot, I would go up to, if I knew Bigfoot lived roughly in Montana, I would spend my time camping up there to find it. And if I was a flat earther, I would passionately be looking for the edge of the world and nothing would fucking stop me and I would evidence it. And I know this is, that's an old script or that's old stuff. But for the impassioned flat earthers that are not on a quest to photograph and evidence the edge of the world, I think they're just.
How do you know it's not an infinite plane, though?
Let's pretend we went to the edge and took a photograph.
How do you know it's not an infinite plane? What makes you think there's an edge, or it's such a huge plane that you couldn't cross it in one lifetime, no matter how fast you went?
Well, I haven't heard their models exclaim that. I've, as a matter of fact, seen a rounded out models that they keep presenting. And so I presume they believe there's an edge as well. And the infinite edge is one that I don't hear of. So
you've never heard of Infinite Plane Society?
Jake's pointing out your straw man.
Yeah,
it's not a straw man.
Very few people actually adhere to the infinite plane.
No,
society.
because I did that we live with where you can breathe. If you guys believe that's air that you're breathing, I think that you flat earther or round earther, you're just way off, right? You guys haven't heard of there's no air model, the matrix model? Well, that's the real model. And if he's going to present and say I'm straw manning because what we're saying is there's an infinite earth, an infinite plane, well, that's news to me.
Can you talk a little bit more about the matrix
model? Sorry about it.
That's
matrix model is just there's no air. There's no atmosphere, right? There's clouds. There you blow. That's just sensation. That's just body sensation. There's no air.
That's chemo shit right there. No,
you sound like a capitalist.
That's fine, guys.
I don't care.
Let him finish what he's saying. I've asked him not to interrupt, so I'll just trying to interrupt him.
Is that what you believe?
Is this a real thing? This is interesting to me.
Hey, Kosha, you should know
there's
about
three
this.
different levels of these things that you call clouds, and then when you blow on your hand, you think you're blowing, but you're not. You're indicating to your hand to fire that thing, and when you see storms or tornadoes, that's just a matrix occurrence. Like you're really just wired up, but there's no density and there's no air, and and light is janky, and trigonometry doesn't work, and I like to eat green slime.
So this is a joke, okay?
No, it's not a joke, Kosho. It's a reductio.
Wait a second. That sounds like
I think where I'm from, we just call it a joke. But,
No, do you know what Kosho? Don't you know what a reductio is?
The guy's just a Poe, and
he's not Poe.
I agree.
He's not a Poe. He knows what he's talking. Look, listen. He knows what he's talking about. He knows more about logic than you do.
Right. So whenever somebody asks him, "Do you fucking believe in the Matrix model?" and he says yes,
it's a reductio. Do you know what a reductio is, Kosho?
There's no need to condescend people in here.
Kosho, do you know what a reductio is?
Oh, you're just joking.
Just explain what.
Can you just
Kosho.
explain it instead of asking him over and over?
Well, I'm looking for some sort of indication that he's even listening. Do you know? Do you know what a reductio is?
Kosho, Brenda is using big words to impress you, bro.
It's not actually a big word.
I was about to say, if you think that's a big word, you got problems, SC.
A reductio ad absurdum. It means that I'm going to propose. I'm going to take your argument to its ridiculous conclusion. The base argument of flat Earth is ridiculous because it leads to the same ridiculous conclusion that I am not actually breathing air.
Well, Brenda, do you agree with this? That if you're 99% empty space, therefore you're more nothing than you are something. So we would say that you're not something.
We're not 99% empty space.
We're not?
No.
You sure?
Yes.
So these physicists are wrong when they talk about, when you zoom in with a microscope, you get closer and closer, that there's nothing.
Well, when I look at pictures of atoms in a material, they are packed close together and there's no room.
And what do those atoms consist of? Something?
Yes, they are full of something.
Okay, but are they made up of something that?
Yes, neutrons, protons, and electrons.
Hear me out. So if they're moving around, right? Are they moving around in a space that is nothing? But they're a little something moving around in a certain amount of space?
No, that's not how it is. That's not how it works. So the way it works is that there's the Pauli exclusion principle, and electrons occupy all the available shells that are available to the electron.
So,
and it's not possible. It's not possible when an electron occupies the lowest shell available in an atom. It is not possible physically for another electron to occupy that same space.
So is electrons, and this I'm not trying to be funny or anything. So are electrons matter, or are they?
They're matter.
Like a focus point of energy.
They're matter.
What do they consist of?
An electron is
one electron.
An electron is a fundamental particle.
So it's just made up of one thing called an electron. Okay, so what is that? Is it a certain type of?
It's
element?
A fundamental particle.
Okay, but what's it made of?
It's not made of anything. It's a fundamental particle.
Is it made of fundamentals, Brenda?
No, it's a fundamental particle. It means that there is nothing else of which it is made out of.
Gotcha.